Awesome, we're live. So, let's see. Had some emails from people verifying repository access, and those all looked good. A lot of people got their repositories up and pushed. Any questions at this point as far as that first programming assignment, getting into Git, getting things hooked up, so on and so forth? And yeah, the sun is definitely shining, which is nice. Spring is coming. I wasn't sure it was going to happen this year, but it's going to happen. Yeah, I know that first assignment is definitely the hardest one we've had all quarter. All right, so yeah, let's dig into Git just a little bit more. Let's look at this business of subdirectories because that's new, and also since I'm anticipating slash hoping people are going to be a little more Git centric right now, let's look at a few of the things that can kind of go wrong and what to do about them with respect to Git. So. Suppose you've got a whole new setup here. You've got all your stuff over on Git, but you've got a new laptop or a new system, or you just lost your hard drive or something like that, right? So the first thing is pulling down your repo from Git, right? So you've already got this stuff up and running, and you want to make a copy of it. So wow, I've forgotten all my shortcuts. There we go. So git clone, right? So I'm sitting in a directory here. It's the root of my 223 stuff. I'm gonna say git clone, git at gitlab.com :username, and then the name of the repository that you want to make a copy of with a .git at the end. And that will pull down your entire repository and it will create a subdirectory under your current account with the same name as the repo. So now if I go into this, I've got my files that I set up the other day, but I've also got my full history of everything I've done on Git, right? So all of my commits that I've made and changes and so on and so forth. And so I've got two directories under here. I've got PA-A and I've got PA-1, right? But it's one repository, okay? And everything's going to be in this one repository called CSE223 submissions. And so, when you get to PA2, let's say we're going to call that PA2. I'm just going to make a directory called PA2. Here's my main program. And I'm going to add, commit, git push origin master, right? Now I'm sitting in a subdirectory here called PA2, but I'm still in the same repo. Okay, you're not making another git remote add origin. You're not making a new repository on the website that you have to add me to, right? It's all just one repository. But a repository, has a whole directory structure, just like a regular directory on Unix. So if I make a clone of this, here's what I'm going to see. I'm going to see some files and some directories. And it's, these directories are no different from just plain old files. You could have 5.c files and a .h and a make file, and you can also have some subdirectories. So we're just going to keep adding subdirectories here to push over our new projects and such. And so if you're interested in cloning and checkouts and things like that, we're working on a single branch for the most part here. Okay, so we're not going to talk about checking out. We're not going to talk about git branch and so on and so forth. You get plenty of practice of that next year and the year after. But for here, we're just going, single developer, single branch, and if you know how to do multiple branches and you want to do that, of course, that's perfectly fine. But we're doing a more simplified version of Git at this point. So here's my Git setup, right? And if something accidentally happens, I lose my mind for a moment and I say rm-rf star, and all my work is gone, right? Not a problem, right? I can get rid of that whole directory, and I can just do my git clone. And there's my new copy of it again. All right, now here's the other thing that can happen. Right, so a lot of people will be working on more than one system. So you've got say your laptop at home, but you also want to work on the Linux server sometimes, right? So let's go ahead and pop up a new window here. And let's suppose I want to work on the Linux server. All right, so here's my directory structure, and I want to make a new copy of my repository on the Linux server itself. So I'm going to do my git clone. Now you have to set up your SSH, handshake one time for any machine that you want to do Git on with say GitLab, but that's just a one-time operation. So what have I done? I've made a copy of my GitLab repository on two machines, right? Here's my home laptop, and here's my account on the Linux server. And they're totally separate, independent copies, okay? But you can make them work together. So so let's say I change my README. All right. Now, pretty obviously, that has no effect on the README on this totally different machine, right? But I can take the README that I just modified on the Linux server, and I can push that into my GitLab repository. So I can add README. I can commit that, and it's still just local, right? Git add, git commit changes it on the repository, in this case on the Linux server, but now I can push that over to GitLab with git push origin master. And now on GitLab itself, these changes have been applied. But still, my README over here is just my plain old README. Why? Because I haven't pulled down those changes from GitLab. If I want to, I can say git pull origin master. And now it's telling me I'm taking this branch that's on GitLab, I'm merging it with my local copy. Okay, and it's like committing. I can put in messages here. I'm just going to leave this message saying, the change I'm making is a merge from the master branch to my local branch. And now if I look at README, it's got my new README on it. All right, and I can change, my README here. Git add, git commit. And I can push that over. And then on here, if I say git pull, right, that's got my new README. Much serious. All right, so that's the ideal setup, right? Every time that you make changes, you push them into the repository. Every time you go to a different machine, you pull from the repository to get the latest copy, and then you make more changes and you push those over. Okay. here's what can go wrong. So I'm over here on the Linux server. I make a change to README. Right, so there's my very serious comment. All right, so far I'm totally fine. I've made some changes to my files. I pushed them to my repository. I come back the next day and I'm on my local machine and I decide, oh yeah, I need to make a change to my README file. So I'm going to change my README. All right, here's what happens. I try to push this, I'm going to get an error. Okay, and you've probably already seen this happen. You get an error, failed to push some references, updates are rejected because the remote contains work that you do not have locally. Okay, this is exactly what's going on. I made some changes over here. I added haha to the end of my README. I pushed it into GitLab. And now I've made some different changes on my local machine, and I'm trying to push that into GitLab. And it's not going to let me do that. It doesn't know which changes to make. Right? So in the past, I've said, you know, well, if this happens, just you know, delete your repository and take your current directory and make a new repository from it. And that's the kind of quick and dirty way to fix this. But that's pretty heavy-handed, right? So let's see what's actually going on with this. And when you're doing group work with other people and you're sharing your code through Git, this tends to happen a fair amount. And it's caused in this case because I forgot to pull before I made changes and pushed. Okay, it's a really easy thing to have happen. So here's what I can do. At this point, I can say, okay, let's go ahead and pull from GitLab. And it will tell me automatic merge failed, right? Fix conflicts and then commit the result. So it was trying to reconcile the version of README that was on GitLab with the version of README that I've just made. Okay, and it's warning me that there's conflicts. So let's go ahead and look at README. And you see some extra stuff has been added. Okay, these first 3 lines, these were all the same. This was the line that I added locally. This was the line that was added and sitting in GitLab. Okay, so it's showing me that, you know, there's a conflict here. It can't decide which one of these should be kept. Okay, but you as the programmer and someone who can talk to the people who made other changes and so on, right? You look at this and you figure out what is this supposed to be. Okay, well, yeah, so it was supposed to say not too serious, and the haha wasn't supposed to be there. All right, there's the version that I want. I'll push that in. Well, I'll add. All right, so that's pushed, and now I'll come over here and I'll do my pull, and we should be all in sync now. Right, so there's the README over on my Linux server, and there's the README on my local machine. Everything's synchronized now, and now as long as I keep going forward, and I keep things, you know, legit, pull before you make changes, push after you're done making changes, right? This should not happen. But if it does, you know, that's a little bit of how you can fix it up. If you're just doing Git from one machine to GitLab and back, this usually doesn't happen. But it can still happen, you know, if you make major changes on your local system, like you delete all your files and you pull them from another directory, right? Git can get confused. So that's just something to, yeah, it was just random type. Yeah. Oh, so that code at the end when, oh, I lost it here. But when we looked at the README that had both pieces of code in it, and there were all the less than signs and all the greater than signs and that big long hexadecimal number down there, those are things that can be used by automated tools to relate those lines in the message to the actual lines in the original file. It's kind of like when you run a difference on two files, you get a bunch of output that's not really human readable, but can be used by a program called patch to apply those differences. So yeah, so that's all other details. All right, so that's more than you probably ever wanted to know about Git conflicts and resolving them, but there you go, freebie info. Yeah, there's so much more to Git, and I don't know a lot about Git. I don't have a lot of experience using it in kind of a real team development setting, but there's a lot of information out there. And it's a pretty cool system. All right, so let's talk about objects in Java. Yeah, it's definitely good for teamwork. But these kinds of things like merge conflicts and stuff start to come up a lot when you do development in teams, unless you have a really good understanding up front shared by everybody on how you're going to manage your repository. So one thing you always want is you pull before you make changes and push, right? And you always push your changes over to keep everything in sync on the server. But when you start working with branches, it gets really complex, and you gotta have some planning up front, right? You have typically what's called the master branch, which is the main one that's out there, but you might have a development branch where you push over finished changes that still need to be tested, and you might have issue branches for each thing that somebody's working on. But you got to have a clear understanding, when do things get pushed to which branch, and can anybody push those, or is there one person who's responsible for pushing, and all of this stuff. And inevitably, if you just kind of have 3 or 4 people jump into sharing a repository without that understanding, you get all kinds of interesting late night discussions. Like, hey, all my code just disappeared, or all the code that I had working suddenly broke, and things like that. So we don't get to go into a lot of that in the sequence here at Clark, but you'll definitely get opportunities to learn that in the next year or two. And yeah, it can happen without Git issues. All right, let's talk about objects. So in C we have these things called structures. So we could have structure student, and it could have an integer ID and a character name, and and maybe an array of struct classes called schedule that references all the classes that the student is taking, and so on and so forth. So a bunch of data, right? And structures are nice in C because if you have a bunch of different sets of data that logically belong together, this lets you organize them in a way as effectively a new data type. So, if I wanted an array of students, yeah, I could have an array of IDs, I could have an array of names, I could have an array of class schedules and do the parallel array thing, where, ID bracket 3 is the ID number of student whose name is names bracket 3, whose schedule is schedules bracket 3, right? But that's a pain. So we can glom these all together into a new data type called a student. And then we could say, struct student, S1, where S1 is a student, right, a struct student. Then if we want to know S1's ID, what do? We say S1.ID. And if we want to know S1's name, we say S1.name, and so on. And this is, if S1's actually a structure. If it's a pointer to a structure, we use the arrow. We're not going to worry about that. So this is you know, a structure. These things over here, we've been calling these things fields. So ID is a field, right? It's a type of variable inside the structure. Name is a field or a type of variable within the structure. We're going to do the same thing in Java. Okay, we're going to define these new types of variables that can have multiple types of information inside them. But we're going to go one step further, and we're also going to allow you to define not just pieces of data, but also pieces of code that are part of this structure. So if we wanted to add a class to a student's schedule, right, we might have something like, you know, an add method, an add function, that we can give it a class and it will add that class to the student schedule. And then if we had a student S1 and we wanted to add some class to it, what do? We do exactly the same thing. We would say s1.add and we'd give it the name of the class that we want to add. And so behaviorally, right, syntactically, this looks exactly like just accessing a field. We're accessing a part of this structure, but this part happens to be a function. That's not a problem, right? It's just another piece of this structure. But it can be code as well as data. Okay, why do we care about that? Because usually when we have a structure and we have a bunch of pieces of data, they're related to each other in some way, right? We're not storing, you know, the temperature of, every day of the last year inside this structure, right? We're storing information about a student. We have functions that lets us do things, right? We have a function that lets us add or drop a class from a student's schedule. We have a function that lets us calculate a student's GPA. We have other functions. We have functions that tell us the length of a string or give us the square root of a number, right? We don't take the square root of a student, okay? We don't calculate the GPA of a floating point number. So you have sets of data and you have sets of code, and some code it makes sense to use with certain sets of data, and some code and data don't logically belong together. So the idea of an object here is really we're just grouping together not just the data, but also the code that makes sense as something that belongs with that data. We're glomming that all together into kind of the superstructure, which we call an object or a class. And that's really useful to do because, for example, I might have an add function as part of a linked list package that I've written. I might have an add function as part of a queue package that I've written. Well, now I've got an add function as part of, something for dealing with students. And when I want to add a class to a student's schedule, what do I want to do? I want to make sure it doesn't conflict with anything else in the student's schedule. I want to look up their prerequisites and make sure that they're satisfied, and so on and so forth, right? All that code can be glommed into as part of what it means to be a student. And I don't have to know, I don't have to call some add function and pass it the student name and the ID and the schedule and all that. It's a piece of the student, okay? So that's the basic idea of where we're going with objects, okay? So yeah, that's exactly why an object is different than a struct, right? Because a struct in C is really just data. When we think of an object, we're thinking not just of data, but also of functions. Okay, we're going to play around with strings as a specific example of this. Let me pin down some terminology up front. So we'll use the words class and object, and they mean different things. Okay. So let me go back to C again. So suppose we say struct I'll stick with student. Okay, and then at some point we say struct student S1, S2, S3. All right, this thing up here, this is telling me what a student looks like. It's not actually referring to a particular student. It's the blueprint. Okay, it's the description of the things that comprise a student, which is an ID and a name and a schedule and so on. Down here, I'm declaring variables that are struct students. Okay, so S1 is a struct student, S3 is a struct student. Okay, so loosely speaking, in Java, this is going to be called a class. And these things are going to be called objects. All right, so a class is like the structure itself. An object is a particular instance of that class. So objects are instances of a class. Class is the description of what it means to be a student. An object is an actual student. Okay, don't worry too much about the terminology, but we'll be using these terms a lot, and this distinction will become more clear over time. So let's start off by looking at strings. So one of the nice things about Java over C is that Java understands what strings are. It's a built-in data type in some sense. But what it really is it's a class. Okay, it's like there's a structure that's been written for us that defines what you need to know in order to describe a string. So what do we need to know about a string? Well, we need to know the characters that comprise that string. We'd really like to know how long the string is so that we don't have to deal with null terminators anymore. We'd like to actually just record the length of the string, HELLO. Let's store a 5 somewhere and say there's 5 characters in here. But we also want to be, a little more modern, so we're not just going to assume that these 5 characters are ASCII characters, because ASCII is US-centric, right? American Standard Code for information interchange. So we'd like to be able to use Unicode, or something more universal for storing these. So we want to know the coding of the characters in our string, and probably a lot of other stuff as well, right? So the string is going to be a more complex data type, right? And it's a class. So let's write some code. All right, so I've got a file called test1.java. I've got to be defining something called test1. My main program's always going to be public static void main. My argument is going to be a strings bracket bracket. And I'm just going to make S1 a variable of type string. Let's see, still confused on the difference between a struct and a class. Structs are not a thing in Java, okay? There's no struct statement in Java. There's a struct statement in C. There's a class statement in Java. They're kind of similar, except that a class is like a structure that also includes functions, right? So the real difference is, when we think about a structure, all you can put in a structure is variables. when we think about a class, we can put in variables, but we can also put in functions. Okay, that's the main difference that we care about today. So classes are like structures, but they also include functions. But yeah, as someone just said, C is structures, classes are Java. All right, so so string is a built-in class. We don't have to declare or include anything. It's built into the language for us. And I'm declaring a variable here. Let me do this in pieces. So I'm going to declare S1 to be a string. And here I'm going to give it a value and say S1 equals hello. And then I'm going to print the value of S1 with a print line statement. And that's the end of my main program and the end of my class. And I'll compile that. And I'll run it, and it says hello. Not too surprising. Yeah, no need for string copies. Mostly. Yeah, it is kind of like string natural log. So yeah, so Java is mostly indifferent to spaces, except, you know, inside quoted strings or functions or things like that. But, you know, this will work perfectly fine. And this will work perfectly fine too. All right. Ooh. I forgot my countdown clock. All right. All right. So strings are a thing, right? And we can declare, you know, a value when we declare the variable. And that works fine. And we can concatenate strings. Right? So we can concatenate strings just by putting in a plus sign. And yeah, comments work the same as in C. So you can do // on a single line, or you can do the long notation. All right, and we can do concatenation with a plus sign. And this means we can mostly avoid all the stuff that we encounter with printf. Because I can do things like this. The value of S1 is, and I can say plus S1, and it'll do what you would hope it would do. Are there dictionaries in Java? What do you mean by dictionaries? So there's Java documentation available that I linked to through Canvas. I've got my own man page command where I can just say doc. No, I can't. I broke it. No, there's not a built-in man page as far as I know, but we can set one up pretty easily. Um, yeah. Give me one sec. Yeah. So I've got my own man page shortcut set up, so I can just say doc and type in the name of a class, and it'll pull up the documentation for it. Um, but you get pretty good at working your way through the documentation. Um, all right, let's see. Would those strings be global? So scoping is kind of a different story in Java, but it's very similar um, to C. So I'm inside a function here called main. S1 and S2 are local to this function. Um, if I were to declare a function, a variable right here, that would be global within this whole class. We'll have to get into that later. All right. So suppose you want to know how long a string is, right? In C, what do? We call the string length function. So we would say, print out the length of the string. Something like that, right? That's not going to work in Java, and it shouldn't work in Java, because string length, right, is some function, right? If I include, string.h, then string length probably comes from that, and I have to know that string length is a function that corresponds to strings and expects a string. But there's this disconnection, right, between this function and the fact that it should be operating on a string and it should return the length of it. Okay? So we don't write something like this. Right? That's what we would do in C. What we're going to do in Java is, because S1 is a string, we're going to look to see if there is a part of the string class that corresponds to length. So if we look at the documentation for a string, and this documentation all looks the same, okay? It's a very standardized structure to it. So the class name is string. We'll talk about a lot of this later on. But there's, some discussion of what a string class is all about. There's ways that you can create a string. Well, we cheated. We just created a string by saying, equals double quote. But we'll talk about constructors later. But methods. So a method is a function. It's the object-oriented term for functions. So method summary, function summary, same thing. These are all the things we can do to strings. We can say, show me the character at some position. We can say, compare this string to another string. We can say, concatenate strings. We can do that with a plus sign too. We can say, is one string equal to another string? Okay. We can also say length. And length is a function or a method that's part of the string class. And, this is all linked, so if I click on this, I'll get more details here. Length is a method that returns an integer, which is the length of the string. Number of Unicode code units in the string. So how do I find the length of this string S1? Just like this. Alright, so this is what we call the goods. Okay, the length of S1 is S1.length. Okay, if it were a structure and we said S1.length just like this, we would assume we had a field named length, and we were asking for the value of that field inside S1, right? But length is not a fixed field. It depends on what the contents of the string is. So length is actually a function, right? And so we're saying s1 dot length paren, right? And it's that paren that's telling it that this is a function. So yeah, length is a function. We don't need to print %Ds. I can just concatenate. Yeah, method and function are synonymous. And we don't need to send anything into the paren. I mean, what would we put in there? There's nothing we need to tell the length function, right? What is it going to take the length of? It's going to take the length of s1. How do we know that? Because we said s1 dot length. All right, so let's run this and then let's start modulating it. All right, so the length of s1 is 5. So let's make s2 something more interesting. So we'll make s2 a longer string. All right, so let's print out the value of s2 and the length of s2. All right, so s2 is, this is a longer string, and the length of s2 is 23. So yeah, methods belong to classes, exactly. All right, so yeah, I'll put this code on the shared code area you can get to through Canvas. But this is a really good kind of first hit at an example of classes and objects, right? No need for a null terminator because strings actually have a length built into them. Now we don't have access to that as a variable, right? It's inside the class, but we can get to the value of that length variable by using the length function. And we don't have to put anything inside the parentheses. And in fact, if we try to do that, we're going to get a compile error. And it's going to say right here, s2.length parentheses 1, character sequence.length is not applicable. Actual and formal argument lists differ in length. It's telling us, that's not the same length, it's telling us that the length method expects no arguments, but we called length with a single argument, which was an integer, and it doesn't know what to do with that. So it's not even going to compile it for us. And yes, the Java docs tell you what you can or cannot pass. So if we look at length, there's no option here, right? It just takes paren. But if we look at character at, right, that's a method that takes an integer, which is the index of a variable, and it returns a character, and it's the character at that position. So on assembly code level, question, Java doesn't even use an null terminator? Probably not. It could. We don't know, and we don't have to know, and we're not supposed to know, right? So this is this firewall that we started working on in 222 with abstract data types. The fact that, all we need to know is that when we call length with no arguments, we get back the length of the string. We don't need to know, and we shouldn't have to know how that length comes about. It could be stored as a separate variable. It could be that there's a null terminator, or again, it could be the length function sends a text message to someone on an island who says, hey, remember that string that you stored? Tell me how many characters are in there. And the person says 23, and the length function returns 23, right? And none of that is going to change how we use the length function. Those are implementation details. right? So yeah, encapsulation. That's the key word. Could be a person on Gilligan's Island. That would give them something else to do. Um, and they've got, you know, bicycles and bicycle powered radios, so they should be able to handle implementation of the length method. How did you access the Java docs again? So you can link to it through Canvas, or just go into Java string class will usually get you there, right? So look for docs.oracle.com, and that'll get you there, and bookmark something around here. But I have a shortcut I set up a while ago that that'll let me get to it. All right, so let's play with character at. So let's do some looping. Let's look at the characters in S1. So I'm going to say character I. All right, so I've got a hey, DuckDuckGo, yes. So good old for loop, right? This is just like a C for loop. I'm locally declaring an iterator in here I, so I goes from 0 to the length of S1 minus 1, right? So I less than S1 dot length, I plus plus. And then I have one big long print line here which says print character, and then I'm going to concatenate the value of I after the string character. So it'll say, you know, character 0 in S1 is, and then I'm going to look at what that character is. And I'm going to get that character by using the character at method, right? Which is just this method down here. It takes an integer, returns a character, right? And there's no %s's, %d's, %c's, right? We can do that if we want, but we can just concatenate. Here's a string. I'm going to concatenate an integer. I'm going to add on another string, and then I'm going to add on a character. But it's going to come out looking really great, right? It's going to be just what we would hope it would be. If you don't forget to match your parentheses. And the error messages in Java tend to be pretty useful, but again, same game as usual. Look at your first error message, right? In this case, it said, hey, line 22 of this file, I'm expecting a right parentheses. If that's not enough, here's line 22. Here's where I'm expecting a right parentheses. That's just about, you know, as plain as you could hope, right? So yeah, fix that, compile it, and then go ahead and run it. And, you know, character 0 is H, character 1 is E, and so on and so forth. Does car at number also work for ints? No. So if you have an integer, you can't, it doesn't have a car at method associated with it. You'll get a compile error. Always frustrated me how phones are the only form of tech we don't truly own. Well, yeah, it depends on how you look at that. I was reading a thread on potatoes that was warning someone, like, you know, if you replant tomato seeds, you might be violating your end user license agreement when you bought them. All right, so that's a first look at objects. Okay, we will continue with this tomorrow and dig further into this, and then we'll be able to talk about PA1. PA1's posted. You can start taking a look at it, but we'll jump into PA1 tomorrow probably. And see what we're doing for the first long programming assignment. All right, cool. So So kick this around in your heads. Come to office hours if you have issues. Finish up PA-A, get that pushed over, and I will see you tomorrow.